This video introduces the transmission system network model and demonstrates the AC load flow calculation. Study case 01 load flow should be activated together with scenario base scenario. The study case time is set at 1700 on the 12th of January. This network model contains profiled demand, and this time represents a peak winter demand. The project includes 3 diagrams representing the entire network. The overview graphic has simple representations of the sites and the connecting lines. The network consists of 4 grids and has been colored according to grid. The grid graphic has more detail, showing the individual bus bars, generators, and loads. There is also a geographic map of this hypothetical network and a separate diagram for each grid. The load flow can be run using this icon on the main toolbar. Let us look first at the basic options. A balanced AC load flow will be run with automatic adjustment of taps for phase shifters, transformers and shunts, and the reactive power limits of generators and SVSs will be observed. On the active power control page, the active power control is as dispatched, with any mismatch between generation and demand being taken up by the reference machine. The load flow command is executed. Notice that different graphic coloring options have been selected for when a load flow has been run to show the voltages of bus bars relative to nominal and the loading of edge elements such as lines relative to their thermal ratings. You can see how the lines connecting the northwest grid to the southwest grid are colored orange. They're heavily loaded at over 91% of their rating. As mentioned previously, the load flow command has been configured to place any mismatch between demand and generation on the reference machine. To see where the reference machine is, we can open a Network Model Manager and look at the synchronous machines. On the Load Flow tab, it can be seen that the reference machine is SWG8. Let's mark this in graphic. We can see that the active power from this machine is currently about 539 megawatts. To demonstrate the balancing role of this machine, let's switch off generator SWG1. The load flow is then rerun. Now we can see that the mismatch is balanced by additional generation on SWG8. Generator SWG1 is switched back on, and the load flow run once more. We could alternatively use F10 as a hotkey for these repeated load flows, as we don't need to change any settings. Let's look again at the overview diagram. The coloring indicates that most substations are at or close to nominal voltage. Details of the voltages can be seen in a Network Model Manager. Here, the flexible data page has been configured to show voltages when a load flow is run. This icon can be used to change the default number of decimal places in the project settings. We can filter the output if, for example, we're just interested in the northeast. Let's look at the substation NE03. Currently, its 2 bus bars are at the same voltage, so it would be interesting to see what would happen if we split the substation. We can split the substation from the grid graphic by double-clicking on the bus coupler to open it. We rerun the load flow. And we can see how the voltages are now quite different on the 2 sides of the split. The breaker is closed again. Returning to the load flow settings, you can see that there is another active power control mode called According to Secondary Control. In this mode, the generation dispatch is managed by power frequency controllers. In this model, there are two power frequency controllers which can be seen in a Network Model Manager. One controls the 4 synchronous machines in the southeast to maintain the flow across the northeast-southeast interconnector boundary to a specified value. Here, the value is set to -200 megawatts. The other controller controls the remaining synchronous machines so as to balance the network, in this case, dispatching them according to their rated power. To see the impact of changing the active power control mode, let's first run a load flow with the active power control still set to As Dispatched. We can see that about 158 megawatts is being exported from the southeast. Now, we'll change the setting to be according to secondary control and run the load flow again. The generation has been adjusted to ensure a 200 megawatt transfer across the boundary. This video has demonstrated the basic load flow command. There are many other options available for the load flow. Have a look at the user manual for details.